Alright guys, we're going to continue our lesson with another set of hydrocarbons called the alkenes. Now alkenes, like alkanes, they combust and burn in the presence of oxygen or hydrogen, okay? They combust like oxygen. But they have a carbon-carbon double bond. The carbon-carbon double bond, which makes them more reactive. This carbon-carbon double bond allows alkenes to be classified as an unsaturated hydrocarbon. The reason it's unsaturated is because this double-double bond, this reactive double-double bond, can pull apart and break up and form single covalent bonds with other elements. And this will make alkenes very useful for several industrial applications like making plastics, a whole bunch of plastics, like even to saturate vegetable oils like olive oil into margarines. Alright, so let's talk about the structure of some alkenes. And we're going to start with ethene. Remember, means two, so you have to have two double-double bond. And it's going to merge with four hydrogens. And we're going to draw the hydrogens like so. Alright? Propene means that there is 3 carbon atoms, but only one of them is a double bond. So you can either draw it this way or this way. Doesn't really matter. They're both the same. Okay? So, because if you count the atoms, 1, 2, 3, or 1, 2, 3, it's all going to be the same. And so you would draw the hydrogens this way. Now you may ask me, Mr. Cole, why is there only one H attached to the middle carbon atom? Well, if you remember your octet rule, you should know that carbon can only form 4 bonds, right? So if you look at this carbon, there's 1 bond, 2 bond, 3 bond, 4 bonds. And this carbon here will have formed 1 bond, 2 bond, 3 bonds, so it can only form another bond with another hydrogen. Whereas this glass carbon here has 1 bond, so you have to create 3 new bonds with the hydrogen atom. Okay? So remember we talked about you can also draw it this way. It's not an isomer now, because if you flip this molecule by this axis here, you can see it can be superimposed on this one. So this is not an isomer, it's just a propene. But I'm just drawing it in more variations so you can look at how it can be drawn. Now for butene. Butene has 4 carbon atoms, right? Now you're going to ask me, Mr. Cole, where can we draw the double bonds? Well, you can draw here, here, or here. But I'm going to stick with this one, right? And I'm going to fill up with hydrogens. Or I can draw it with this, a double bond. and I'll fill it up, the gaps with hydrogens. All right. Now if you look at this, one of the butene has a double bond on the end side, towards the end of the molecule, and one of the other butene has the double bond smack in the middle. Now this makes these two molecules an isomer, structural isomer. So what is the name for this one? Well, if you count your carbon, 1, 2, 3, 4, or you count it backwards, 1, 2, 3, 4. The name could be, you could try to guess the name to be either but1ene or but4ene. But by conventional IUPAC standards, we have discussed this, that it should be the other way around. So 4 should be the smaller of the two numbers, so 4 gets eliminated, and the name, official name is but1ene. Why did we put the 1 right smack in the middle? Because it's to allow us to indicate that this ene is at the first carbon atom. So if that is the case, we shall continue counting this one for the other isomer, 1, 2, 3, 4. And we notice that the double bond is on the second carbon atom. So its name will be but2ene. All right? And in class, we'll do more exercises about naming names with longer alkene chains. So the general formula for alkenes is CmH2n. The H is twice the number of carbon atoms. Now, to close up this whole entire unit, we're going to talk about the types of reactions of alkenes. Alkenes are not found naturally from oil and gas fractional distillation. They have to be made through a process called cracking, in which we will talk about next time. All right? Now, when alkenes are made, they become very important precursors for a variety of reactions. For example, if I take an ethane and I subject it to bromine gas, aqueous bromine, I can get a sub-addition reaction whereby the double bonds will break and form bonds with the bromine, and this bromine now, and this molecule here now will be called 1,2-dibromoethane. All right? Remember about the naming conventions. We have 2 carbons, so we write ethane. 2 bromo, so it's dibromo. Where is the bromo located? On the first and second carbon atom of ethane. So it's 1,2-dibromoethane. And this becomes a colorless gas. And this little property from converting orange bromine solution into colorless solution, liquid solution. This is liquid, yeah. Colorless solution is a way that we can test that an ethane product is available. Okay. Another addition reaction of ethene is through a process called polymerization. Polymerization, which is putting lots and lots of ethene together to form extremely long chains. All right? And we'll talk about that in the polymer unit. Let's get back to ethene. And ethene can also react with hydrogen gas, right? And you will get what you get, ethane. If you react ethene with water, or not, this is not water by the way, steam, you can get ethanol. And of course, you can combust ethanes like you would with, like you do do with hydrocarbons. So that is the unit.